Excellent. Well, thank you. So I have an idea who the audience is. So basically, my name is Marko. I've done a lot of Android training for some large carriers and phone manufacturers so far. And what you're seeing now is just what's normally a 3-4 hour session that we're going to put down in half an hour or so, and talk about just the high level 30,000 foot view of the platform, what it is, how it works, etc. So we're going to look at the big picture. We're going to look at what the main components of the application are. For some of you, this is going to be different than what you're used to from programming in different environments. We're going to look at the structure of a project, what a project looks like. So I'm firing up my Eclipse. I'll show you the actual hello world type of thing. The SDK components, and the actual application. So how many of you have actually seen this picture before? Because this is kind of the stack. That's the big picture. You guys seen this before?
I've seen that kind of image before.
Got it. Okay. So basically what we have is at the lower level, we have the Linux kernel. So that is kind of like the lowest level components that provides the hardware abstraction, yada, yada, yada. We'll talk about that. Then we have the libraries. So basically this area here, that's the stuff that Android is borrowing heavily from other open source components, and it's providing some major bits and pieces to make the platform work. And then we have the Dalvik virtual machine, which I'll talk about as well. It's pretty important. Application framework, it's essentially all the supporting components for your environment. And then we have your applications at the top of the stack. So I'm going to go through each part of the stack, starting at the bottom, and kind of like just do a couple of main points about it, and then we'll warm up that way. So basically, the Linux kernel provides, it's the lowest level, so Android runs on Linux, essentially compiles against a Linux library, right? So if you have a libc, it's actually not a libc, it's their version of it. But as long as you have that, you can compile everything for that specific platform. And it provides, what that does is provides an abstraction layer. So if you want if a manufacturer of a phone wants to deploy Android on, say, Atom, right? Is that the Intel one? So you can compile for that platform and have it all work on that in theory. So right now we just have it on ARM. That's what's working. That's what's proven, and so forth. Linux provides for memory management, process management, networking, all this kind of like low-level stuff that needs to be done. And essentially, as a user, you never see the Linux operating system. As a developer, you never see the operating system. So this is something that, it's more of an interesting thing to know. And I know some of us are going to want to poke around the lower level, but for the most part, that's not that important. And then we have the ADB shell, which is a command line tool that gives you a total access to your phone. So I'll show you that later on. It's actually pretty cool how you can get into your phone, either emulated or actual, and play with that. So we'll look at that. Native libraries provide for things such as Surface Manager, deals with like the actual screen, things of that nature. 2D, 3D graphic rendering engine that's built in. It uses OpenGL, for instance. Media codecs, so everything from rendering for different movie formats, audio formats. There's a SQLite database built in. That's kind of cool to know I guess, for some of you that deal with databases. So you have a full-fledged SQLite database built in. Browser engine, it uses WebKit, which is the standard HTML rendering. Android runtime. This, in my mind, this is the crown jewel of the whole application. This is where the most kind of innovation has gone into, but it's not something that you necessarily, either as a developer or a user, necessarily experience. So it's very low level. Essentially what's happening is the code that you write in Java gets compiled into the Java binary code, but that's not what runs on Android. So that Java bytecode then gets recompiled into something called DEX. DX, which is basically a Dalvik implementation of binary code. And that is what essentially runs ultimately on a Dalvik virtual machine. So it's a totally different approach to a virtual machine. I don't know much about the design of virtual machines, but one is register-based, the other one is stack-based, right? So regular JVM is stack-based, this is register-based, or the other way around. So it's one of those philosophical differences between how to design a virtual machine. The point is, JVM, Java Virtual Machine, is designed to one size fits all, anything from mobile devices to like supercomputers. It doesn't necessarily work very well for a tiny device such as a phone. So Dalvik re-engineered that and made it work really well. As I said, it compiles into DEX. Ultimately, it runs as a DEX file. When you use tools like Eclipse, you never really notice any of these things. So it's just kind of nice to know that it's actually Dalvik that executes at the end of the day. But as a user, as a developer, you're just coding in Java, and you don't really care about a lot of this stuff. In terms of application framework, these are kind of the ecosystem components that are provided to your app. So, for example, there's the activation manager, which is going to drive your application through its life cycle, start it, stop it, kick it out when the memory is low, that sort of stuff. So it kind of provides that, that life cycle management. Content providers. Content providers is the Android approach to sharing data between apps. So remember, we're writing for a tiny little device, and applications can be downloaded by users. So you have to address security issues, right? What happens if users accidentally start downloading viruses, wiping out their phones, etc.? They're not going to be happy. They're going to call AT&T or whoever their provider is and walk away. So we don't want that to happen. So one of the considerations that designers of Android system did is that to sandbox each application. So each application is going to have its own sandbox that it can run on. That's it, right? And now if you want to break that barrier between apps to communicate back and forth, one of the ways is using content providers. So it's a very simple, interface. It's basically a CRUD interface: create, retrieve, update, delete. So to share the data back and forth. Resource manager manages everything that is a resource, and resources are everything that's not code. So there's this concept of, in Android, you write code to create your application, but then you're going to have all the other stuff. The other stuff could be XML, for example, for values, and XML to inflate your layout. We'll talk about that, UI and things like that. And you have images, the little graphics, the little buttons to click on, maybe a movie clip, things like that. Those are resources. So Resource Manager manages that for you. Location managers, including for Wi-Fi network-based location, GPS, things of that nature, as well as sensors. So all the sensors would be part of that kind of management system. And Notification Manager, for those of you who have seen, has everyone seen Android phone, actually how it works or anything like that? Cool, so you have a G1, cool, or Dev 1. So Notification Manager is what helps with notifications to the user. And while we're waiting for this, I'm going to just kickstart a emulator. So hold on a second, let me just do this emulator. It's one of those tools that I think it's EMU or Android. Let me do this. So if, I want to see which phones I have available, and so I have this emulator 99. So for example, so I'm going to kickstart that device, MU99, so that you can actually see what the actual phone looks like. It's going to pop up shortly. So this is part of the SDK tools that we get. So you develop against an emulator. It's much easier than against the actual phone. Works the same way for the most part. So they're pretty much the same thing. Okay. The exception is when it comes to sensors, things like that, because on the emulator it's really hard to kind of manage that. So I'll just let this start up in the background while we are talking. So, or I'm talking, so that you can see what it looks like. And then finally, at the top of the stack, we have apps. So these are the little things that you start. And applications are such as phone, email, contacts, web browser, marketplace where you can download other people's apps. your application can go there and stuff. So one key component here to notice is that unlike iPhone, all applications on Android environment are equal, right? So they're considered equal. So for example, iPhone is great, you can download apps, but say, for example, you don't like the calendar that comes with it, or you don't like the SMS app, you're just over the little bubbles, right? You want to replace it. Well, you can't, because on iPhone, apps that ship with it are superior than anything else, right? You can't also write applications that run in a background, things of that nature. On Android, to kind of compare it, on Android you can replace every single app. So you can get rid of your calendar, you can replace your SMS client, you can have multiple SMS clients compete for users' attention, right? You can have whichever type of application you want, you can replace it. Even the home screen, which is the main application that kind of hosts it all, kind of equivalent of desktop, I guess, on a regular desktop computer. So you can replace every single application, and they can run in the background. So it's kind of like, you know how your Microsoft Windows ships with IE, but you don't like IE, you download Firefox, right? It's kind of like that. You can have multiple apps, and then the user gets prompted and says, hey, would you like this to be your default, you know, web browser or phone application? So that's kind of cool. Just to kind of show you what that looks like. So this is what a phone would look like. So I can open it up. So I have, this is the home screen. It's the application that you can kind of like, you know, move around. It's got a drawer where you keep all the apps, right? So you can, you know, you can, for example, start your app that says contacts, and you have some contacts there. You can like open up a contact. So this would be one application. I can go back, or I can just click home and go back to the home screen. So that's, from the user's point of view, what an application looks like. The notifications that I was mentioning earlier, so that's the little drawer that you open up here. I got no notifications right now, but that's where, if I did, that's where they would pop up. So that's essentially what that looks like at the high level. So let me move to the next slide. So now we're going to talk about some application components. So this was kind of like the stack, what the overview of the stack is. Now I just want to kind of mention some of the key programming components, kind of like the building blocks, right? And on Android, they're different than on regular, what you're used to in different systems. So one of the constructs that Android has is something called activities. So a way to think of an activity is kind of like in a website, you have a web page. That's what you're currently looking at, right? And a website can have multiple web pages. Typically has a home, right? And then it has about us, contact us, etc. So activities would be equivalent of a web page. So a application can have multiple activities, right? One activity would be the one that initially starts up. And basically an activity represents something that is visual on the screen. Typically an activity takes an entire screen, right? It doesn't have to. So for example, if I was here and if I clicked on dialer, so the activity that I have visual right now is this dialer screen. I can now go to another activity that is giving me a list of my people who I have called recently. Another activity, etc. So these are various activities. They're all part of the same screen, for instance, or same application. So that's what an activity is. I have, yeah, I'll show you some examples later on. So another construct that we have is an intent. An intent is basically a messaging that we have between the different parts of the system. Usually an activity to activity, it could be activity to a service. We'll talk about services, etc., etc. But basically, it's a way to send a message and potentially get a response back. It's kind of like on the web, you have a request response. You click on you make your HTTP request by opening up a URL, right? So an intent is kind of like an URL, a message you send, you get some data back. Typically, it's a typical intent would be, hey, you know, I click on a dial and I would like to start a dialer, or actually start calling the number. So that would be sending a message to another activity. And the reason why it's done via intents is to it provides for a way to break the barrier between apps. So remember, each application is in its own sandbox. So for example, if my application wants to tell the dialer to dial a number, it sends a message via an intent and says, hey, start dialing, you know, this guy's phone number, right? So that would be one example of that, of an intent. But intents, you can have explicit intents where you say, I want this app to respond to it. But you can also have implicit intents. You say, I would like a web browser, a web page to be shown. And now this sends an intent. It says, who's capable of opening up a web page, right? So it goes kind of like up to the system. So you say, I would like to perform open up a web page. It goes back to up to the system. And the intent resolver, whatever upper echelon of Android says, OK, I got 2 apps that are capable of fulfilling this message. And that sends back a message down to those 2 apps and says, which one of you is going to open up this application, so this URL. So that's kind of how that works. It's a pretty lightweight app-to-app messaging mechanism. It's pretty cool. The other one that we kind of mentioned, it's the content providers. So content providers is, again, a way to break the barrier between sandboxes of the applications, but in such a way for sharing data. So it's not so much to make a request and get a response, but it's more for, hey, I would like to get some data from you. Can you please provide it back to me? And this is really neat because even internally, the apps that come with Android heavily use this. So give you an example. You have an address book, right, on your phone. Everyone does. So now if I'm writing a new app, say a Twitter app, for example, and I want to add most of my people that I already have in the address book to show up in my Twitter application. Well, I have 2 choices. I can build a brand new database and have a brand new secondary storage mechanism for all my people. And then I would have to maintain 2 lists. And on one hand, I have 1,500 contacts. On the other hand, I have none. So it kind of like, it doesn't really work that effectively. Nicer way would be for my Twitter app to ask the contacts app, hey, can you give me the list of people that are already there? Right? So that's what the content providers do. It provides a mechanism to ask for some data and get some data back. Right? So you can do your basic create, retrieve, update, and delete. Or it's query, insert, update, and delete into the content provider. Now, a content provider may require certain permissions from you. It's typically a user that says, yes, I download this Twitter app, and yes, I approve of it using my contacts. So it's up to the user's discretion to grant or not grant the privileges to something like that. Yeah.
Yeah. Now, like say filtering, like say I only want to bring up my personal contacts to Twitter. That would be the responsibility of the respective applications. There is a little bit of stuff that you can do, and it's up to the content provider to provide the business logic of serving or not serving certain data, excluding certain data, and so forth. So it's not free for all. It's really content provider is the gatekeeper of that data. The way the content provider works is via content URI, and a content URI looks like a URI, like a URL. Right? So if I wanted, I would say something like content column / contacts / all or / Joe or / 47. So that would get a specific or all contacts that match that criteria. Or I can say / contact / starred and gives me the starred contacts, right? Or / contact / contact group, for example, friends. So there is a little bit of that, and it's really it depends from content provider to content provider. But the mechanism looks like a URL. It's kind of like, or a web service, like a REST kind of deal. So contacts are one example that serve that. All the settings on the phone work the same way. So if you want to write an app that's checking or changing the settings in your app, you can use the same mechanism. Media, for example, works the same way. So for example, I snap a photo of something, right, with my camera. That photo gets stored somewhere, but its mere existence and all the metadata about it are provided to me via the media interface. So if I now want to write another app that's taking the advantage of the existing system media files, right, I would just ask the media store for what photos are available that fit certain criteria. or what movies are there, and so on. So that's how all the media is stored. Yeah.
So what you're saying that if you develop your own application, certain data that required by your application, you may need to write your content provider yourself if it is not.
That's correct. Yes, you may, if you want to expose your, so I mean, this provides for loose coupling between parts of your app, and you may not care about that, right? But if you do want to provide your data to expose it, so this, I was talking here more as being a user of a content provider, but if you want to expose your data, you just write a content provider interface, and it's a very simple interface. It just basically provides your 4 basic operations. You probably already have, it ends up in practice being almost a proxy to your database calls, because you're going to have your insert, update, delete to a database somehow, so you kind of write another interface that just has a certain, matches a certain interface, essentially. So it's a Java interface. So yeah. But for example, phone information, like my most called people, that's call log, that's their browsing history, bookmarks, etc. All that stuff is stored in there. So it's a pretty cool mechanism for sharing data. Finally, we have services as one of the components. So services is a very simple application that runs in the background. So service is what kind of like an application minus activities. So it doesn't have any UI. It doesn't have anything user-facing, right? So that's kind of what a service is. It can run in the background. You can bind it to an activity so that you can get back to it, and so forth. So types of services would be like music playing in the background, something listening for your SMS messages coming in and throwing notifications and saying, hey, you got a new message, right? So those are things that would be a service. This is something you can quite easily do in Android and you can't do in iPhone because it doesn't support services, for example. So that's a type of application that is very, very useful. So
when you develop an application using the Android, do you need to pay attention to your memory? Because you have that limited amount of memory. You cannot take up too much memory.
Yep.
Is there any guideline or anything?
yeah, we'll talk about that. Actually, yeah, I have a little diagram how that works. But basically, the application ends up being driven through a certain states. So let me just kind of pop that up really briefly for you to kind of show you images, an app lifecycle. So this is what the lifecycle of an application looks like. So an application gets started, it ends up running, gets paused, stopped, eventually destroyed. Now, you don't do any of this. It's the activation manager, it's the system that decides, okay, user clicked on a favorite application, and it says, is this application running? If it's not, it starts it up, right? So now your app is running. So as long as it's user-facing, as long as it's interacting with the user, and you only have one activity ever kind of in the forefront, just like on a website, you have one web page that is in your face, right? There could be others back and forth, but that's a click away, right? So similarly, you have one activity running, and you could, for example, get a phone call, and that is interrupting whatever you're doing. So that activity would get paused in that case, right? So it kind of goes, it's there, but it's kind of in the background, right? And that's what the paused would be. An application or activity could be stopped. So, for example, you're playing with it, but you just haven't used it for some time, so it gets stopped. So the system decides when to get rid of it. So the way it works is kind of simplified explanation of the way it works is if it's an activity that's running, it's pretty much guaranteed to get all the necessary memory. So the one that's in your face, user-facing, that one gets the memory. The one that's paused usually means it's there, but it's visible, but it's not focused. So it could be that it's something that's in the background, but it's not really interacting with the user. So that one is also going to get some memory because it's in user's face. It's visible, right? Stopped means it's not being used at all. So it's there, but it could disappear at any moment. Okay? So that's basically what that is. And the system decides when to get rid of it. So if it's running low on memory, it's going to start killing all the stopped ones. Okay? If it's got memory, then it's going to keep your apps in the in memory for a time being, because chances are we're humans, right? So although I have maybe 30 apps on my phone, I really use 3, 4, 5 of them most frequently. So why not keep it even for days, weeks in memory, if that, you know, if there is plenty of memory, right? So one way you can find out what's running in your phone is you can you can keep on going to your different applications, yada yada yada. But then this is the app that I think we do in a class. So you can kind of like build like a list of restaurants, things like that. But if I want to now find out which apps I have running, I can click on this, and it shows me the so it's a long press on your home button, and it shows you the list of applications that you currently have in memory. You don't have a way as a user to kill the app. You don't. You just kind of, if the app, if I want to go back to it, it gets, started. But if it hasn't been started, then it's going to get created and started and all that stuff. So that's kind of how that works in a nutshell. Does that make sense?
Yeah, in a way, but it looks like the application has no control when it will, stop, because it looks like it's user-driven and depends on the memory, and it can be killed at any time.
Exactly. So that's a very good point. So it's a different type of programming than what you're used to. If you're programming for desktop, you are starting your app. You have your steps 1, 2, 3, 4. You are controlling the process from starting the application to actually exiting the application. That's how we program for desktop, right? Here we're programmed reactively. So we are basically just filling in the blanks. We're just filling in the callbacks that are going to get called by somebody else, by that upper echelon of Android, right? Namely, the activation manager.
But how do they decide which one to kill? If I have, like, on the phone, I have 10 apps open, right? So different applications, because it's equal quality, as you said. So who to kill?
So it's going to figure out which ones to kill based on how much it's got a simple management of memory. From my experience, it kills every 6th one, right? You can have 6 apps in memory, and then 7th one is going to get killed when another one gets started. But that's just because my apps are very small, right? If I had a app that is like takes much more memory than others, different things could happen. But basically, the way it does it is to optimize users' experience, right? So, but as a developer, you're only guaranteed that running app gets all the priority, and running and paused. Stopped is prime for destruction. Now, you don't know if and when the destruction is going to happen. But if you need something done before it gets destroyed, before it gets stopped, when it gets recreated, yada, 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 you fill in the blanks. There's all these callbacks, right? Hooks, right? On save instant state, on pause, on restore, on resume, on destroy, and so on. So those are the bits and pieces that you fill in. Make sense? So it's kind of like reactive programming. You're filling in the blanks, and that's basically what we do to program for Android. So that's kind of that. Let me just kind of make sure that we cover the other stuff. Oops. Services. So structure of a program. Basically, let me just start a simple. What I'm going to do is a simple application to show you how that works, so you can kind of get a sense of it. So I have Eclipse with built-in SDK, Android SDK, right? So it kind of looks like this when you start it, minus all my example codes. I have zillion and one example codes, as you can see. So if I was starting a new app, a new project, I would create a new Android project. And a project is an Eclipse construct. It's not an Android construct. So I would give it a name. So I would say hello world. And of course, I have hello world. So I'll say 77. I probably don't have that one. So that's, just give it a name. That's an Eclipse construct. Now you have to select, this is new since 1.5. There's going to be different packages of Android. There's going to be Android vanilla. There's going to be Android with Google APIs, such as Google Maps. There's going to be Android with I don't know, Sony Ericsson APIs, this APIs, that APIs. So it's quite likely vendors are going to do add-ons to Android. So that's what it's asking me here. It says, which target do you want to compile this project against? So this is going to make this means that your app is going to require at least that. So of course you want to require the least common denominator so that your app can run on most phones, right? Unless you really require that proprietary DRM or something like that. So I'm going to say I need at least Android 1.5 here. Application name is just an arbitrary name. So hello OSCamp people. So that's my application name. Package name is your Java package. So it would be something like com example. Okay. Activity name would be, remember activities are like kind of home pages. So, I mean, kind of like web pages. So the one that you specify here would be kind of like your home page. It would be the initial activity, the one that gets started first. So you could have multiple ones, but this is the entry one. I'll say hello world. I'll say hello, yeah, hello world. That's fine. And you click finish, boom. And it just goes and creates a bunch of stuff when it does. So that's that. So let me just show you what we just built. So hello world 77 is right here. So we have a bunch of folders here. Source is where your source files are, okay? And they're in a Java package. So I'm going to have a Java file. We're going to look at this file later on. I'll get to that. Generated code is a generated code, and I'll refer to that in a little bit, so hold that thought. Assets is where anything that's an asset goes. Resources is where your resources are. So resources are anything that is not code, right? So little images, graphics here and there, but also XML files. And one thing that Android does a lot of is try to separate your values from your code. So for example, even the fact that I put that name hello OSCON people or whatever I put in there, that's a piece of text. But that didn't go into the code. It actually went into a separate XML file. So you can kind of see that under values, strings. So for example, that piece of data is shown here. So there's my hello OSCamp people, right? So it kind of separates it externalizes any piece of data. That is very good when it comes to supporting multiple devices, supporting multiple languages, all this stuff. Your Java doesn't change. You can translate it into Chinese quite easily without recompiling any piece of code. So that's good. And then we have finally the manifest file. The manifest file gives you kind of the high level metadata about your app. You know, it kind of specifies that this is an application that uses a certain drawable icon that has a certain label, and it also shows you that it's got one activity, and that activity responds to a certain intent filter. Don't worry about what that intent filter is. It's kind of like the public static void main in Java. It's kind of like your entry point. That's essentially how it describes that, but don't worry about that too much. You might have noticed that the tool SDK has this, whenever you're editing an XML file, it has like kind of like an intelligent XML editor or simplified XML editor. So as opposed to changing XML here, I can do it via an interface like this, right? As opposed to changing the simple XML here, I could change it via this view. It does the same thing. So if you like GUI tools versus getting dirty with the code, that's what that is for. So that's basically my little app. And the final piece that I didn't show you is the layout, and that's this one here. It's another resource. Basically, what the layout is the UI for your app. So this resembles a screen, right? And what Android does, and this is one of the really cool things, I think, you can design your user interface in plain old Java, something like similar to Swing or AWT, if any of you have experience like that. So building button by button, right? My button equals new button, that kind of stuff. You can do it that way, or you can do it in XML and then inflate it into Java in space from XML. So that tends to be much faster. So if I do it in XML declaratively, right, I can do things like, you know, toss in buttons and toss in, like, for example, date picker and you know, other widgets like that to my screen. You know, putting in progress bar, putting in some spinner, things of that nature, right? So you essentially can put stuff like this in here, and ultimately it just ends up being part of the XML for that screen. And then what happens in the actual Java file is we inflate all our source, all our layout from something called a resource. So this refers to that XML file. There's this very neat mechanism to link the Java world to the XML world, and that's via something called R class. So R class is automatically generated, and it refers to everything in your resource. So if I wanted to refer here to my resource, which is main.xml, I refer to it by r.layout.main, and as you can see, that matches this resource layout main, right? So what is R? R is a file that is automatically managed by Java, by SDK. You never have to worry about it. You never have to start it. Just poof, it's right there for you at all times. So, but it's basically a bunch of integer pointers to your resource. So just kind of want to show you for your own amusement, but not really to worry about it too much. So let me just save this main that I changed, and let me fire off this app. So I'm going to try to run this application. I'll run it like this. I'll right-click on it and say run as Android application. Save it, sure. And basically what happens is this gets compiled into Java and then compiled into DEX. Resources get compiled also, and then everything gets bundled into something called APK file. And that's basically a deliverable. You get one single file that represents the entire app, and that gets installed into the phone, and it finally runs. So this is my little app that I just wrote. It's not much, and you guys have a hard time probably seeing it on the screen, right? But there's a little spinner, and there's the date. Oh, is that better? Yes. Oh, there you go. So yeah, so there's a little you know, and all these components we got for free, and we inflated them from XML. Okay. So and this is an activity you're seeing, and this is an application. Here's the piece of text that I have. Again, that piece of text was externalized into XML, and so on, and so on. So it's pretty neat set of tools, and it's a pretty neat system. So those are those. When you download an SDK, you get a bunch of tools. You get system images. You don't really care about that. You get some sample codes, documentation, add-ons. The key is you get the Eclipse plugin, which makes life so much easier, like with this little drag and drop stuff that I just showed you. And that was the Hello World app. This is the application lifecycle that we talked about. So my application is now started. I don't know when it's going to get, you know, destroyed or not. I just know that, you know, if I go back to it, right now it's active. If I go back to it, you know, I don't know what's going on to it right now. I should be able to find it in the drawer. So it's probably one of the Hello Worlds that I have on the system. I have a zillion of them. It's somewhere there. Or I can just do a long press on my home, and there's Hello OSCON, and it pops it back up. So that would call on restart method. So in terms, it would basically drive it being the system, the activation manager would drive it through the state machine, essentially. The states are as follows, right? Active or running, so it's in the foreground. We talked about it. Paused means it's kind of visible, but not really. Something is abstract. Maybe it's like a dialog box above it. Stopped means it's completely obscure. So if it goes missing, it's not a big deal. Who cares, right? If you want to start it again, as a user, it's going to get started again. So to a user, it doesn't really matter if it got killed and recreated or stop then restart it. It doesn't really matter. The system does it based on memory resources that it's got to optimize the user's experience. One of the most expensive things that an app does is actually create itself, right? Because that inflation of the UI, creation of the UI, that's super expensive. That's where, you know, it's 2 orders of magnitude than performing a simple operation. So that's kind of why we have it that way. So these are different callbacks. These are basically the blanks that you fill in. You don't have to. The only one that you really have to, you know, is on create. But as you saw, even when you just do a blank project, it's going to start up and it's going to say hello world, right? So it's pretty good as is. Resources, we talked about that. Everything is a resource. They're stored in a resource directory, and then that R class that glues, that makes the transition from Java to resources is automatically generated by the tools. So you don't need to worry about it. This is example of various resources, what that XML looks like. So I have strings, I have arrays. So you want to externalize all this stuff so that you can easily provide, say, translated version of your app or version of your app that's going to work in a different screen size or portrait mode versus landscape mode, etc. As I said, the XML editor makes it really simple to create different versions. It's based, ultimately everything's based just on a naming convention. So for example, if I wanted to create a version of my my strings for a different language, there's this little editor that I can use. Say for example, I want to create new values for different language, right? So I would put, for example, say I want French, FR, okay, and I want to create for different country code. So I'll say, sorry, country code, this is for, I always do this, this is for mobile operators. It's region as opposed to country code. The region says CA, so for Canada. So now, if I want to provide my language translation pack for French Canadian, right, I would just basically put it in this file, values-fr-rca. And you can do that for keyboards, orientations, networks, etc. So let's call this, you know, strings, strings.xml, and basically just creates a second folder where I can put my French version. And if the language is set on the phone to be French, it's going to pull the French version. So it's a very simple mechanism. It's based on a naming convention. In terms of security, I think we talked about that really briefly. So each app runs in its own actually Linux process. So it's each app is its own virtual machine, its own process. So it's pretty secure. As a matter of fact, it gets its own user ID. So it's like app 010203. So it's managed like that. It's got its own part of the file system, which is also readable only to that user ID. So that's kind of how it's all that managed. So it's a pretty sandboxed in. Applications cannot access each other's data. We talked about that. Critical operations, user has to grant the permission rights, such as, you know, should it be okay to make phone calls or get online and you know, create a bill when you're roaming, that sort of stuff. You get to, as a user, choose yeah or nay, and all that is managed via the XML, the manifest file. So basically, I know we are kind of like at the time. So basically, the summary is that it's a very cool platform. It's open source. You write it in Java, but it doesn't run Java. But who cares, right? So it's much more practical to create apps in Android than it is in for example, J2ME environment, just because it's much more it's designed to get one job done properly. You know, a lot of components like UI components are done for you. You don't have to go and recreate, say, tabs like you do in J2ME environments like that. Unlike other platforms like iPhone, for example, all apps are equal. You can run background processes, etc. Uses most common design patterns. So it's pretty standard stuff for a lot of people who do development in other Java or other languages, and it's a different approach than designing for a desktop because you're doing this fill in the blank strategy, right? So as opposed to running a program that sequentially runs, you're rather filling in the blanks for callback methods that are going to get called by the system. So that's kind of like just a high-level overview of what the platform is. You get a lot of tools for free and so on. So make sense? Did you guys get it?
I think it's something I want to delve into.
Got it. Cool.
Thanks.
So I'm guessing that it's, if you have to use Java to do it, you can use Jython, which is...
Yes. You can, if you want to, now, so if you want to write in a different language, say, for example, you want to use Python to write your Android apps or Ruby to write Android apps, you can do it as long as it can get compiled into the Java bytecode with Jython and JRuby, you can do that, right? And then that's going to get converted into DEX and it's going to execute. The only concern is that the Android libraries that ship with it come as Java packs. So you would have to do the binding to the other language packs to make that possible. But yes, it's in.
I guess that's done when you do.
People.
Jython. I don't know anything about JRuby, but.
Yeah, people have done it. So
That's great.
yeah, yeah, totally. Yeah. Cool. Any other questions, comments? No. Cool. Well, thank you, guys. Thanks. Thank you.